Hi everybody, and welcome to our Unit 3 video on phase diagrams. We're going to show you what a phase diagram is, and more importantly, how to read them, how to evaluate one. A phase diagram, like the one at the right hand side of the video screen, is simply a graph that shows the state of matter a substance will exist at under different pressure and temperature conditions. First of all, some basic things. You see the area on the left hand side here. That's the solids. Solids will typically occupy this space, the low temperature region on the far left. That should make sense for pretty much all substances at very low temperatures. That's when they're going to solidify. So that's where you'll find the solids, here where the temperatures are low. For the same reasons, gases typically occupy the high temperature region on the far right, and liquids will typically occupy the middle region between the two. It's important to know where these sections lie because they're not always labeled for you on the graph. Next, and more importantly, is how can we use these graphs? What kind of information can we get from them? There's a list of 3 things I'm going to give you here. The first being you can identify the state of matter at any given pressure or temperature. I could ask you a question like this: will the substance be a solid, liquid, or gas at atmospheric pressure of 1 atm and 200 degrees Celsius? Simply find the pressure, 1 atm, follow the line over. Find the temperature being requested, 200 degrees Celsius, follow that line up. Where they meet indicates the state of matter. So this substance would be a gas at that temperature and pressure. Second on the list, you can also identify the normal boiling point or melting point of the substance. Normal here meaning whatever the boiling point is at atmospheric pressure. Sample question could be, what is the normal melting point of the substance shown? Since normal always means 1 atm or atmospheric pressure, you find the atmospheric pressure line, follow it over to where the phase change would happen. Since we're doing melting point, that's going to happen between the solid and liquid phases. That temperature corresponds with 0 degrees Celsius. So therefore 0 degrees Celsius would be the normal melting point of this substance. Just to go over everything, we could also follow that 1 atmosphere line over to the liquid to gas phase change. That's going to be your normal boiling point of 100 degrees Celsius. Third and finally, you can identify different phase changes that will take place as variables are changed. A sample question for this could be, what phase change will take place as the substance is warmed from negative 100 degrees Celsius to 25 degrees Celsius at a constant pressure of 0.005 atmospheres. Start off and find the pressure being mentioned. You could estimate 0.005, maybe around right here. And the temperature being mentioned is negative 100. I'm just going to place it somewhere around right here. Then you sort of draw a line to represent a warming from negative 100 up to 25. I'm going to put my 25 right around this point right here. If you follow that line across, whatever phase boundary you cross represents the change that took place. So in this case, solid to gas represents a phase change of sublimation. The final thing we need to talk about are just some other interesting points you can find on these phase diagrams, starting with something called the triple point. This is the temperature and pressure condition where all 3 states of matter exist at the same time in equilibrium with one another. On this graph, it's going to be where all 3 lines meet at point A. That is the triple point. Finally, we have something called the critical point. This is the temperature and pressure condition above which no phase boundaries exist. On this graph that is seen as point C, you can see the line stops. The colors also kind of blend together up here, indicating that there is no longer a clear distinction between liquid and gas. It's easier to see on this graph. It's a little more open in the top right. This supercritical region now contains a new state of matter, which we call a supercritical fluid. A supercritical fluid is best thought of as a gas that is extremely dense, close to the density of a liquid. This actually concludes our video on phase diagrams. Please enjoy the recap to follow.